Welcome to the Ducks Unlimited podcast, the only podcast about all things waterfowl. From hunting insights to science-based discussions about ducks, geese, and issues affecting waterfowl and wetlands conservation in North America, we bring the resource to you. The DU Podcast with your hosts, Chris Jennings and Dr. Mike Brazier.
Today I've got my co-host, Dr. Mike Brazier, in studio with me, and we're going to talk about a very important topic as far as habitat conservation goes. Ducks Unlimited's work all throughout North America focuses on supporting the needs of waterfowl, among other things, obviously. But we talk about duck energy days, basically a duck use per day as far as habitat goes. Mike, we need you to explain exactly what a duck energy day is so that as we continue to talk about this on the podcast and we reference this in the magazine and, online, our audience will know exactly what a duck energy day is.
I'll be happy to. It's good to be here with you, Chris. That many professionals, academics, researchers across our profession have made significant parts of their career in studying the concept of duck energy days, duck use days. It dates all the way back to 1979 and late 1970s. Dr. Harold Prince, from a former professor from Michigan State University, is credited with some of the very first work in kind of documenting this concept of a duck use day was the first term that was used back in the late 70s. And at its most basic description, a duck use day, or as a duck energy day, as we'll transition to in our discussion later on, is a measure of the carrying capacity. It was conceived as an easier term to speak to the carrying capacity of a wetland, of a given area of a habitat type, or of some larger region in the carrying capacity of those entities to support waterfowl. And it's rooted in the science that tells us during the non-breeding season, one of the most important things for waterfowl is access to high-quality habitats that provide dietary energy, calories. We're talking about calories. So the simplest description of what a duck use day is, it's the amount of energy required, amount of dietary energy required to support the activities and the existence of an average duck for an average day during the non-breeding period. And there's a lot of things that kind of go into the specifics of an average duck on an average day, and we might get into some of those to a degree, but at its simplest level, it's a measure of carrying capacity for waterfowl.
How are they going about calculating this on everything from a 20-acre wetland to the Gulf Coast?
I have spent many years dealing with bioenergetic models. Those are the models through which we use this concept of duck energy days for our conservation planning. And so I want to go back to talk about how it kind of began. An interesting fact is a lot of this began or grew from work that was being done in the poultry industry. You think about what they need. They need to know when people are growing chickens, poultry for for meat production, they need to know how much food they need to purchase and provide to support the energetic and growth needs of all the chickens, the poultry that they're responsible for. So if they understand, as these poultry husbandry folks, if they can understand and quantify how much energy and how much calcium and how much protein and all these other nutrients an individual or an average bird, turkey or chicken or whatever the case may have been, needed for a given day, and if they knew how many chickens or turkeys they had in their production, and if they knew how long it would take to take those individuals from hatching all the way to the point at which they're processed, then they can calculate the total amount of food that is needed to support those birds from hatch all the way to processing. So that's kind of the way this all began. And Dr. Harold Prince said, we can probably apply that same level of thinking to waterfowl in our desire to provide habitat. And again, our thinking during the non-breeding period is that when we provide habitat, we need it to provide food. So if we can understand how much food a duck, again, we're talking an average duck here, If we know how much food a duck requires, or how much energy, let's say that.
Now, when you're saying average duck, are we basing this off of a mallard?
We can do it for any duck or goose that's out there.
That was going to be another question, is if you do it for every, okay.
Yeah. So let's just stay generic at a duck energy day. And I've kind of already in this conversation made this transition from a duck use day to a duck energy day. They're kind of used interchangeably, at least they were early on. Here in recent years, a lot of conservation planners prefer to use a duck energy day when we're talking about carrying capacity because it's conceptual. It's a reflection of the amount of energy that's out there in a given wetland. It doesn't guarantee that those wetlands are going to be used by ducks. If you have 10,000 duck energy days in your wetland, it doesn't mean that you're necessarily going to get 10,000 duck use days out of it, because there are a whole host of other factors that determine whether that wetland is used. So I've kind of already made this transition in talking about duck energy days, so I just kind of wanted to explain that. But early on, it was referred to as duck use days. So a duck energy day, as I've said before, reflects the amount of energy required to support a duck for one day. For a mallard, here's where I'll start to get some of your answer. For a mallard, on average during the non-breeding period, a mallard will require somewhere in the neighborhood of 330 kilocalories to sustain itself. That means to kind of maintain its body mass. That accounts for the cost of thermal regulation, that accounts for the cost of flight, that accounts for the cost associated with molt. And again, the term average here is really important because on any given day, that energy demand is going to go up or down based on ambient conditions, weather conditions. I mean, you probably enjoy going hunting on really cold days more than warm days because
Absolutely.
you know that cold temperature is going to drive up those energetic needs of the birds. They're going to have a greater need to go out and find food and forage to offset the cost of thermal regulation. So that's kind of one of the concepts that's at play here. So, all right, so mallard is 330 on average kilocalories per day. And energy demand for ducks, for waterfowl, for all birds is proportional to body mass. And that's not linear, but it's nevertheless proportional. And I know you said you wanted to try to keep this simple, but here I go talking about linear and nonlinear and all this. So my apologies there. But basically, the energy required for a given bird is proportional to its body mass. That makes sense, right? Geese require more food to sustain themselves for a given day than does a mallard. So a person thinking about this might say, well, how then do I know if we're just talking about duck energy days, whether that's referring to a mallard or a blue-winged teal? And that's a great question. In conservation planning, a lot of times what we do is we'll either use a mallard to represent an average duck, or some have taken it even further and said, like in the Gulf Coast where I used to work, we looked at the composition of the waterfowl community that we expected on the Gulf Coast during winter. It's going to be generally smaller birds. We didn't have a lot of mallards show up on the Gulf Coast anymore, so it was mostly blue-winged teal, shovelers, gadwall, species that had smaller body mass and then necessarily had smaller daily energy demands. And so we calculated that daily energy demand based on the composition of the waterfowl community that we expected in that region. And I think it ended up being like a duck energy day on the Gulf Coast was the equivalent of about 214 kilocalories of energy, if I remember that correctly.
Off air, we've kind of talked about the differences between, agricultural field versus, a wetland on the Gulf Coast, and how you kind of explained how that is calculated, but kind of explained a little bit more in the weeds. I know I said you to dumb it down here, but, a little bit more in the weeds about how DU even uses that calculation to then say, here's where we need to work, and points in a certain direction that's completely science-based and science-oriented. How do we go about doing that?
We can use duck energy days in a couple of different ways. From a landowner perspective, I want to start there because, and then I'm going to get to your question about how does Ducks Unlimited use it. From a landowner perspective or habitat manager perspective, they may be interested in knowing how many duck energy days did I produce on my piece of land this year, based on whatever management activities I would have implemented. The way we calculate duck energy days, again, carrying capacity for a given wetland or management unit, is we need to know how much of the food resource is out there. And food resources primarily in terms of seeds from either agricultural grains that are produced for the benefit of waterfowl, or in a lot of cases, it's moist soil, grasses and sedges that produce seeds. Some of those plants produce underground tubers. All of those food items contain energy, different levels of energy. So we need to know what kind of plant species are out there. We need to know what's the biomass, as we call it, how much seed do they produce? And all these things are kind of calculated on a per acre basis, a per hectare basis, if you're using the metric system. And so if you know how much, let's just say moist soil seed, if we can quantify how much moist soil seed is produced on a given acre of a given wetland, and if we know which moist soil species those are, plant species those are, then we can go to some of the literature that's been and research that's been conducted that has estimated the amount of energy contained in each of those different types of plant seeds. So let's say we have some panic grasses, let's say we have some millets, and then let's say we have some other foxtail or some of these other grasses. We have estimates of what's called true metabolizable energy. And I'm not going to get into the true metabolizable energy definition, but that basically says that not all the energy that's in a seed is actually processed by the bird. Some of it passes through, but we can account for that. So for a lot of these different food items that we know waterfowl eat, we have done research to estimate what that metabolizable energy content is. So if you know how much seed you have out there of these different plant types, if you know what the metabolizable energy is for those respective seed types, then you can calculate the total amount of energy that's available in a given wetland or in an acre of a given wetland type. So that then becomes your calculation of the duck energy day carrying capacity for that wetland. Okay, so that's how it's of interest can be used by landowners or habitat managers. From a Ducks Unlimited standpoint, we can come at it from the other direction, because what we're interested in is providing enough habitat to support a given energy demand associated with the waterfowl populations that we're looking to support across the continent, and then, of course, broken down into finer planning regions. And so what we do is, and I'll take the Gulf Coast, for example, but we could do this for the Mississippi Alluvial Valley, for the Playa Lakes region, for the Central Valley of California. We look at each of those regions, and we look at some of the population objectives that have been stepped down from the North American Waterfowl Management Plan for each of those regions. And they tell us how many birds we need to expect to support of different species and for how long within these regions. So those three pieces of information, how many birds of how many different individual species and for how long. And I've already told you that we know that different species have different daily energy requirements. For mallards, it's 330. For others, it's going to be less or more depending on their body size. We then also, if we know how long they're going to be there, like if you have a mallard that sticks around for 10 days, that's 3,300 kilocalories that it needs to sustain itself for those 10 days. 330 for one day, 3,300 for 10 days. So it's just simple math from that standpoint. How many birds of all the different species, and then how many days we expect them to be in those areas. And the expectation of when they're going to be there and how long they're going to be there comes from some kind of historical data, things of that nature. And it varies from year to year. So once you have those pieces of information, it's kind of an accounting, a currency type thing. You just kind of add all that up, and you end up getting to the millions, and in some cases, billions of, well, it should not billions on the duck energy day front, but millions of duck energy days that we would need for a given region. So then what we do as Ducks Unlimited is we use various ways to look at the condition of the landscape. Then we use those estimates of habitat specific, duck energy day carrying capacity estimates. And we see where we are on the landscape relative to where we need to be. And that tells us if we have enough habitat on the landscape or if we need to accelerate our habitat delivery in a given region. Does that make sense?
It does. And I know I said, here we go, getting into the weeds, but are you calculating this a little bit different? Like, let's use the Gulf Coast again, because I know you spend a lot of time down there. You're calculating a duck energy day in that landscape a little bit differently if that habitat has an abundance of, let's say, widgeon grass versus sago pondweed. it's not just one number that can be, or maybe I'm misunderstanding. It can be a different number.
No, it would be a different number.
Yeah,
You're right.
okay.
It's the method of calculation is the same. It's just the numbers that go into the calculations are different. Like if you're wanting to calculate the duck energy day carrying capacity for a coastal wetland in Louisiana that has sago and widgeon grass, you're going to need to know how much widgeon grass and sago is in that marsh. And you're also then going to need to know the true metabolizable energy content of sago and widgeon grass.
Yeah.
Contrast that with an intensively managed moist soil unit in Missouri. You're going to want to know, the associated pieces of information. What are the important plants that are produced in that moist soil wetland, and what are the true metabolizable energies of those plants, of the seeds produced from those plants? So it's the same equation, but the numbers are different because they're different habitats that produce different types of foods.
Now, whether it's a private landowner or Ducks Unlimited coming in, are you taking that Duck Energy Day number, looking at the habitat and trying to absolute maximize that day? Or as in, let's say, a millet, maybe a wild millet, provides much more nutrients than Japanese millet, the variations in those two species. Are you trying to maximize? Are you saying, well, let's turn everything into Japanese millet because it's more productive? Or are you looking for a diversity in there to support, multiple species? Because, you've got one wetland, there's going to be more than just mallards show up at that wetland. Is that something that you guys look at as well?
That's a great question. From a waterfowl management standpoint, that is absolutely something that needs to be considered. Ducks and geese differ in their foraging preferences when you look at the extremes between, let's say, a canvasback and a blue-winged teal. Canvasbacks dive down to the substrate of a wetland and pull tubers out of the mud. Blue-winged teal forage in really shallow water, and they're eating mainly seeds and invertebrates. So it's absolutely critical to think about the different types of foods that are being produced. But the other aspect of what you're talking about there is, are we just looking to maximize energy? I would say no. We're not. If we just maximized energy, then I think we would lose sight of some of the other important provisions from wetlands and the foods they produce. Ducks and geese and waterfowl need energy. That's the one thing that drives them during the non-breeding season, probably more than anything else. But they also need a lot of other nutrients that beyond just energy. They need minerals, they need proteins. The importances of those other nutritional components differ through time. They need fats also. And certainly as we get closer to the breeding season, invertebrates become more important. They become a larger component of their diet. And there's a lot of science to back that up, showing their diet preferences and the shift in those diet preferences as these birds start migrating back north. So yes, we do need to also think about those kind of food quantities, those beyond just maximizing energy. Now, it's generally assumed that when we're producing all this energy, most of those other nutritional components are going to be met. Now, I think if we're just focusing on agricultural grains, I don't know how confident we can be in that. Certainly, if they're dry agricultural fields and we're just talking about waste grain, they're not going to be getting aquatic invertebrates or any kind of protein from invertebrates out of the grain. So yes, those things do come into play, and we do need to take those into account.
Mark Petrie wrote the feature, The Snowstorm, in Jan-Feb 2020 in Ducks Unlimited magazine. And it was in regards to really kind of what we're talking about as far as the habitat, certain habitats. He was kind of focused on the Central Valley. Those habitats have a certain number of duck energy days or goose energy days. Well, that abundance of light geese are kind of cutting into the availability of those duck energy days and those variations. So that's something that maybe our listeners could look at. Check out that feature and look at the differences of how these duck energy days are used in conservation and some of the decisions that we've made looking at the specific species, I guess.
Yeah, that's a great point. That's a good illustration of where our conservation planning. I mean, the reason Mark is able to say that, hey, we've got an issue here is because he understands what the capacity is of the landscape to provide that energy. Again, energy is reflected in a measure of duck energy day We could leave Duck Energy Day out of the conversation and just talk about kilocalories if we wanted to. Both are measures of carrying capacity. Duck Energy Day is just another way of talking about the amount of calories that are out there. But Mark is able to say we have a problem or potential problem because he understands the dietary energy needs of the duck population that we want to support in California during winter, the condition of the landscape right now, and how much food it's providing, Duck Energy Days it's providing, as well as knowing how many geese we have and knowing how much food they're consuming. Those pieces of information, which are all kind of rooted in this discussion of Duck Energy Days and bioenergetic modeling as a basis of conservation planning, those are the things that tell us, help us identify where we have potential issues and when we need to be doing certain things with respect to conservation.
You kind of touched on it, but is it more difficult to quantify a Duck Energy Day for a diving duck? I mean, just based on their foraging capabilities and some of the habitats that they use, is that the exact same equation, just plugging in different numbers, or is there a little bit more to that with a diving duck?
Well, estimating the daily energy need of a diving duck is pretty easy because it's derived from this mass proportionality equation, But I think what you're asking is it more difficult to estimate the Duck Energy Day carrying capacity of a wetland on the basis of a diving duck, right?
Mm-hmm.
Yes. And so the difficulty comes in actually sampling the foods. That it's not, the difficulty is not necessarily in doing the calculations, but it's in sampling the foods because they're at the bottom of wetlands. Sometimes the wetlands are really deep and it takes specialized sampling methods to actually collect those food items. So yeah, from that standpoint, that is the case. Now, there are some species for wood, and canvasback is probably a great example for which we don't focus a whole lot on Duck Energy Day planning for that species because there's not a lot of their habitat and a lot of their food in those habitats that are under strong direct management control. Like if I told you to kind of go out and maximize Duck Energy Day production on the basis of canvasbacks, I mean, how would we do that? There are some places where we can. Delta Marsh is probably the greatest example of that. And we've had a recent podcast episode where we talked about the recovery and restoration of the Delta Marsh. That's a great example where some large-scale restoration efforts can actually enhance the production of food to benefit canvasbacks and other diving ducks. But those opportunities are pretty limited. In most cases, foods for canvasbacks and other diving ducks are going to be dictated by natural processes. Think about Chesapeake Bay. We can't manage Chesapeake Bay from a physical infrastructure standpoint. We can do a lot of things on the landscape to improve water quality. That then improves that system, which then drives the production of those food resources. That's kind of how we do some of that.
Which is very similar to your past work down in Louisiana,
Yes.
where you guys are putting in the levees or the dikes that are out there.
Yeah, water control structures to manage the control of water.
And basically, what that's doing is that's increasing the positive submerged aquatics and other aquatic vegetation.
Yeah.
That then increases that Duck Energy Day.
Yeah, and we certainly do Duck Energy Day calculations down there. I don't mean to suggest that we don't for canvasbacks or any of those type of habitats. It's just that it seems to be more common in those areas which are more tightly, more controlled under certain types of infrastructure.
Yeah, I imagine you standing down there on a dock somewhere in South Louisiana with a gigantic chalkboard with this equation, and you're like the beautiful mind guy, just figuring out Duck Energy Days as fast as you can whip them out. So.
No, not that. Now, one thing that I always try to emphasize here, and I've done this a couple of times already, but a Duck Energy Day, it equals basically an amount of energy in the form of kilocalories. If the person that was making that Duck Energy Day calculation used a mallard as the basis for that Duck Energy Day, then that's going to be different than if the calculation were done for someone that made the calculation based on a blue-winged teal. So it's really important, and this is really in the weeds on kind of the conservation planning, knowing what it is that you're talking about. But I think it also does it helps people. I hope it helps people understand some of the nature of these Duck Energy Days. It's not a guarantee of how many ducks you're going to see. It's a method of calculating a conceptual, theoretical carrying capacity, the ability of a given wetland, given piece of habitat to satisfy the estimated foraging demands, energy needs of a certain group of waterfowl in a given time period.
Yeah, it's basically just a carrying capacity of the habitat for an individual species, if so.
And there's been some work, and actually some of my dissertation work out of Ohio State, maybe I should say the Ohio State University to make all my, to keep from getting nasty grams from all my fellow alumni, that actually asked the question of, are wetlands that have greater energetic carrying capacity, have greater duck energy days in them in terms of food quantity, do they necessarily support more waterfowl than those that don't? Mm-hmm. And there is some relationship there. I mean, obviously at the extremes, if there's a wetland that lacks any food, you're not going to get very many waterfowl using it. But just because you have 5 times the amount of food in one wetland versus another that still has a great deal of resources doesn't mean that first wetland is going to support 5 times more waterfowl. There are a whole host of other factors that influence the number of waterfowl that are actually going to be using that wetland. And this kind of illustrates why the community has shifted away from a duck use day value, except when maybe calculating how many ducks actually use it. So the duck energy day is more conceptual, and duck use day might be, and more oftentimes referred to as what here lately, how many are actually using it. So no, there's a lot of other factors beyond just how much food is in a wetland that determine how many birds ultimately use it. That's probably not much of a surprise to people that have spent a lot of time in the marsh.
Yeah, I think I've heard the duck use day used more in conjunction with like national wildlife refuges. And not necessarily even in planning, but that's just where I've heard that reference. So make sure our audience doesn't get confused with the duck energy day versus the duck.
Well, and if they do, it's okay. It's forgivable because, like I said, there's a whole host of acronyms. There's DUDs and duck energy days and DEDs, DEDs, and there was even MUDs for mallard use day and MEDs for mallard energy days. And so there's all sorts of crazy acronyms that the management community has come up with around this concept.
Now you're absolutely muddying the water. So this has been an absolute eye-opening conversation for me. I've really enjoyed it, and I hope our audience has as well.
Yeah, well, I've probably forgotten a lot of things or overlooked a lot of things that we could go back into. But yeah, it's an interesting conversation. I enjoy talking about it.
Yeah, and I guarantee you could use that same equation for when whoever has an uncle who shows up for Thanksgiving who eats 2 bowls of chicken and noodles or mashed potatoes. You could probably use that same equation to plan this. I'd like to thank my co-host, Dr. Mike Brazier, for bringing Duck Energy Days and the information behind it to the podcast and our listeners. I'd like to thank Clay Baird, our producer, for doing a great job with the podcast. And I'd like to thank you, the listener, for joining us on the podcast and supporting wetlands conservation.
Thank you for listening to this episode of the DU Podcast. Be sure to rate, review, and subscribe to the show, and visit www.ducks.org/DU Podcast for resources based on today's topics, as well as access to more episodes. Opinions expressed by guests do not necessarily reflect those of Ducks Unlimited. Until next time, stay tuned to the Ducks.